My name is Savannah Lacey, and I'm going to talk about substations. Substations are important because without them, we wouldn't be able to have power to our houses, businesses, or anywhere. So, first of all, a substation is part of an electrical generation, transmission, and distribution system. The main function of a substation is to transform power to a conveniently used form for household use, for example. There are many different types of equipment in a substation, like transformers, switches, circuit breakers, and other auxiliary equipment that I will talk about later. So this is a picture of a substation, and it shows some of the different components that the electrical power has to go through before we can use it. So it starts out as 34 kilovolts coming into the substation from a generation plant. And then it goes through all of those different components, which I will talk about some of those later, and it goes out as 7.2 kilovolts. Now, 7.2 kilovolts is still too high for household use, so after it goes out of the substation to the outgoing distribution lines, it travels miles across power lines and reaches another transformer on the power pole, which steps down again to 100-240 volts, which can then be used for household uses. Now I'm going to talk about a few of those different components. So first we have transformers. There are a couple different types of transformers that I'm going to talk about. The first one is power transformer and instrument transformers. The main purpose of a power transformer is to step up the transmission voltage at the generation unit and step down the transmission voltage at the distribution unit. These are required to transform huge amounts of power. The second type of transformer is an instrument transformer. Instrument transformers are mainly used to extend the ranges of the instruments while measuring parameters like voltage and current. These are required to transform very small power because they are used with devices such as protective relays and indicators. So on the top right, we have a picture of a power transformer. As you can see, that is very, very big compared to the instrument transformer on the bottom. Again, that is because a power transformer is required to transform huge amounts of power, while instrument transformers only transform small amounts of power. Next, we're going to talk about bus bars. Bus bars are very important in a substation because this is where all of the incoming and outgoing electrical currents meet. Bus bars can be flat strips, solid bars, rods, or other shapes that are typically made of copper, brass, or aluminum, and they can be either solid or hollow. The bus bar system consists of isolators and circuit breakers, which I will talk about next. So this picture down at the bottom is those bars that you see going across the top. Those are all bus bars. Next, we have circuit breakers. Circuit breakers are used to interrupt any short circuits or overload currents that may occur in the network. A circuit breaker has a fixed contact and a moving contact. Normally, these contacts are touching each other, which allows the circuit to continue. When a fault is detected, the relay transmits a signal to the circuit breaker and the moving contact moves. Once the contacts are separated, the current flow is interrupted, and this isolates the problem so it won't continue throughout the entire substation. So right here is a picture of a very, very big circuit breaker that is used in a high-power substation. And last but not least, I'm going to talk about isolators. Isolators are a type of disconnect switch. They are used in substations to efficiently isolate very high voltage apparatuses such as transformers and circuit breakers when they are due for maintenance. As mentioned earlier, bus bar systems have isolators and circuit breakers. In high voltage power systems, like substations, isolators are used in conjunction with circuit breakers to provide an extra layer of safety. So first, the circuit breaker is opened, which disconnects the circuit, and then the isolator is also opened. And this is a good picture because it shows what isolators look like when they're closed. That's the bottom circle. Those are closed isolators. And then the top with the arrow pointing to it, that is an open isolator. So electrical power flows through several substations between generating plant and consumer, changing the voltage and level in several stages. So, as you can see, substations are extremely important in getting power to the consumer. Thank you.